Here I'm showing you two hyperbolas. Let's talk about the one on the left first, that is in blue. Now the dark blue line is actually the hyperbola. You also see a black dashed line. Those are called asymptotes. The hyperbola gets closer and closer to the asymptote but never crosses it. The hyperbola here on the left opens to the right and left on the x-axis, and we can see that it's going to open to the right and left because the very first term in the equation has an x squared in it. It's the positive one, so it opens to the right and left. Where if we look at the graph on the right here in red, this hyperbola opens up and down. We can tell that's going to be a hyperbola that opens up and down, like the y-axis goes up and down, because the first term is a y squared. The y is the one that is positive. So let's go through two examples here in graphing hyperbolas. So this one is showing you in orange is the standard form of a hyperbola. And our first step is to find and plot the center. So the center is the x1 and y1, and it's what is subtracted from the x and y before we square it. And in this example, there's nothing subtracted from our x and y before we square it. So our center is 0, 0. So let's put a dot there for our center. Now the vertices are either going to be right to left of the center, or they're going to be up or down from the center. And we can tell that based on, again, whether it's what the first term is. And the first term in this case is an x. So we care about A, the x. We want to know what A is. That's the distance from the center where the vertex is going to be. So if A squared is 9, A is 3. So again, it's opening to the right and left, so we're going to go 3 to the right of our center and 3 to the left of our center. Now before we sketch our actual hyperbola, we need to know where the asymptotes are. There's a formula to find the asymptotes, and you'll notice that to use that formula, we need to know the center, we need to know what A is, and we also need to know what B is. So if b squared is what's underneath the y squared, let's say b squared is 4, we know that b is 2. So now we have everything we need to know for the formula. We can start substituting it in to get our equations for our asymptotes. So it's y equals plus or minus b over a, so 2 over 3. Parentheses, x minus the x coordinate of our center plus the y coordinate of our center. So now let's simplify and split that equation into the two equations, our two asymptotes. Notice it says plus or minus. So let's do the plus first. Y equals positive 2/3. X minus 0 is just x, and adding 0 doesn't change it at all. So that equation is y equals 2/3 x. Now let's do the minus. We have y equals negative 2/3 x, and then adding 0 doesn't do anything. So these are our two equations, so now we need to graph them. So you need to remember the slope-intercept form. Y equals, the slope is what's in front of the x, and then we're adding the y-intercept. So nothing is added to either of these, so let's just assume that we're just adding a 0. So the y-intercept for both of these is at 0. So the first equation, the slope is 2/3, so that means we're going to go up 2, and since it's positive, we're going to go to the right 3. Or we could have gone down to the left 3. But positive slopes are always going up from left to right. After you got a couple of those points there, you can do a dashed line through them to draw that asymptote. Now let's draw the other asymptote. Again, the y-intercept is at 0, but it's negative 2/3 slope. So up 2 to the left 3, or down 2 to the right 3. And then just draw a dashed line approximately through those points. Now that we have our two asymptotes, we know that the graph is going to be opening to the right and left. The vertex, we have that point, and it's never going to cross the asymptote. So I'm just going to sketch where that is. And there we go. The one last thing that we need to plot on this is our foci. And the foci are also, they're within the hyperbola, within the opening. It's going to be on this axis, and the foci is going to tell us the distance from the center. So let's just calculate that. The square root of a squared plus b squared. So it's the square root of 13. If I put that in my calculator, square root of 13 is about 3.6. So that means from the center, I'm going to go to the right 3.6. It's going to be about here. And to the left 3.6. That's going to be right here. And the last thing that we can measure with a hyperbola is the eccentricity, which is the measure of how curved, how round it is. And they're talking about this part of our parabola, how round, how circular this is. So what you do is you do a squared plus b squared, the square root of it, divided by a. And a in this case is 3. So remember, this was 3.6 over 3, which is about 1.2. Now let's do one more. This one is very similar, except the center is not going to be at 0, 0. When we're looking for the center, remember that is what is subtracted from our y's, our x and our y. So in this case, our center is 2, 3. So let's plot that over 2, up 3. Now you want to look at it and say, do I care about the A's or the B's for this one? And in this one as well, we're starting off with the X. The X is the one that's positive, so this one's going to open to the right and left as well. So we just care about the vertices is going to be what A is. So if A squared is 4, A is 2. So I'm going to go 2 units to the right of my center and to the left of my center. Now, in order to find the asymptotes, remember, for that we need to know what B is. So let's just solve that. If B squared is 9, then B is 3. So now we have everything we need to know to substitute in and find our asymptotes. So let's just do that. So we have y equals plus or minus b over a. So 3 over 2. X minus the x coordinate plus the y coordinate of our center. Okay, in order to graph this, I'm going to have to do a little bit more simplifying than the last one, but we're going to separate it into 2 equations. Let's do the plus one first, and I'm just going to distribute that 3/2 to the x, and when I multiply 3/2 times -2, I get -3, and then plus 3. If I simplify that a little more, -3 plus 3 is 0. So this first one, I'm just going to put a plus 0. The first one has a y-intercept of 0. So I'm going to start off here, and then I'm going to go up 3 over 2. Up 3 over 2. So this is my first asymptote. Now let's do the other one. So this one, I'm going to do -3/2. So -3/2 x. And then when I multiply that, I get a positive 3. And then another plus 3. So I just distributed the negative 3/2 to the x and the negative 2. And when I simplify that, I get negative 3/2 x plus 6. So my y-intercept is 6, 1, 2, 3, 4, 5, 6. And my slope is negative 3/2. So down 3 over 2. Down 3 over 2. And this is my other asymptote. So now I can sketch my hyperbola. So from my vertices, and I'm just going to make a curve but get closer to my asymptote, but I can't cross it. Now the last step is to plot our foci. Remember, those are on the same kind of axis here through the center. Let's see how far away from the center we put the foci. So that is the square root of a squared plus b squared, which is 13. And so it's actually the same as the last one. It's 3.6 away from the center. So 1, 2, 3.6 here, and then 1, 2, 3.6 here. So these are our two foci. And then the last step is to calculate the eccentricity, how round the curve of our hyperbolas are, how circular it is. So the square root of 4 plus 9 over a, which is 2. So for this one, you get about 3.6 over 2, and 3.6 divided by 2 is 1.8. And that's another key component to describe your hyperbola.